Welcome, Calculus. This is practice for that quiz that you were crying about. So let's begin. Hey, can you see me right here? Close enough. There's a big old thing in my way. I don't care. Hey, so we got to say if these converge or diverge. So this one right here, this looks like that geometric series. Why? Because it has the n exponent right there. So I got to figure out what my r is. My r is equal to 3/5 because that's the thing being n exponented. Now I want to know if it converges or diverges. Does it converge? You bet. Because that's between -1 and 1. So 3/5 has to be between those two to converge. So we say it converges. We have to say what it converges to. Yeah, let's say what it converges to. So the formula is a over 1 minus r. And your a is your first term. In this case, when you plug in a 0, it's going to be just 1. Sometimes the coefficient. So converges to 1 over 1 minus 3/5. You'd never simplify that. I don't care. That's too much work. Let's move on with our life. Next one. This is also geometric, even though it doesn't look like a fraction because I have an exponent. My r in this case is 2, which is way too big, so we say diverges. Excellent. Next one. Does it look like geometric? Nah. Does it look like alternating series? Nah, it has no -1 dealie. So let's try the nth term test, the limit as you go to infinity of n factorial over n squared. Now you can't, so you get infinity over infinity, so we got L'Hopital's rule. You can't derive the factorials, but here's what we got to know. Factorials, this will keep going to infinity, dudes. I mean, this does not go to 0. That's going to go to infinity, so it diverges. Next one. Okay, look at this. We got the n factorial. Now, don't fall for the trap. Some people see the fraction and say 5/4 is our r. That is false. This is the same thing as writing 5 times 1/4 to the n power, since only the 4 is being nth powered. So my r is 1/4. Therefore, this is going to converge. And will it converge to? Well, let's find the first term will be, your a is 5 in this case, so it'll be 5 over 1 minus 1/4. Will I simplify that? Heck no. Moving on with my life. Next one right here. I think this is, converge or diverge. Well, again, check this, a geometric series. Is it? Yeah, it's got this n thingy. Your r is 1/2, so it does converge. What does it converge to? So this is going to converge to your first term. Now, this is tricky. It's n equals 1, so a equals 3 times 1/2 to the 1 power. So it's 3/2. So my final answer is going to be 3/2 over 1 minus. Hey, I'm recording a video right now. We're going to have our meeting still, so it's fine. You can come in. Chill. Come on. Enjoy your life. It's okay. Hey, what if I wanted to simplify that? I'm just going to do it this time. I don't care. It's over 1/2. And guess what? In fractions of fractions is 3/2 times reciprocal 2 over 1. Cancel our life. My answer is 3 over 1 or just 3. Moving on. 3, does that make sense? Does that make sense? Yeah, it does because we start at 1. Okay, because I thought it had to be more than that. Moving on with my life. Oh, this one. So I want to write it as a geometric series. We want to go backwards. I think that's what the question said. What did it say? You know, we're gonna look that up. I'm gonna look that up right here. Oh, there's my mouse. What did it say? Find the power series. Thank you. Find the power series. So basically, turn it into a geometric series. Find the power series means turn it into a geoseries. Geoseries is a power series. I know that gets confusing. Welcome to BC, folks. Well, the formula for a power series is a over 1 minus r. So my a in this case is going to be 1, and my r in this case is 2x. So my power series, the formula, the generic formula is n equals 0 to infinity of a times r to the n power. So in this case, it's n equals 0 to infinity of 1 times 2x to the n power. Cool. Do you have to find out where it converges? Did I even ask that? No. Interval of convergence? Nah. Moving on with my life. Fourth degree Maclaurin polynomial. So you could probably do this with the power series things I tell you to memorize, but let's do it our normal way. So I have to go fourth degree. So f of x is e to the 2x. We have to go down to the fourth derivative. So f prime of x is going to be 2 times e to the 2x because of the chain rule. F double prime of x is going to be 4 times e to the 2x. F triple prime of x is equal to 8 times e to the 2x. Don't forget to subscribe, folks. If this was on Twitch right now, you know, that Twitch Prime money. Get your parents' credit cards. It's okay. My birthday's on the 9th of April. I'm going to let you know. Just reward me. Pass the AP test, please. Yes, I believe you can pass it. Yeah, even you, Randy. Yeah, I know. Even you. You know who I'm talking about. Oh, I shouldn't have called out names. I'll edit this. Don't worry. This won't even be in the video. We're going to edit that part. Yeah, are we? Yeah, we're going to edit. Don't worry. Okay, moving on. What am I doing next? So you plug in Maclaurin. You're centering it at 0. So e to the 0 power is just 1. F prime of 0, this is 2 times 1. It's really just going to be those coefficients because of how it works out. F triple prime of 0 equals 8. F to the 4th derivative of 0 equals 16. So you plug that in. Now you got to remember the formula for that. So the 4th degree, I like saying p to the 4th of x. Sure, you don't. Sure, why not? Is going to be f of 0, so 1, plus f prime of 0, 2 times x, plus f double prime, so 4 times x squared over 2 factorial, plus f triple prime, 8 times x cubed over 3 factorial, plus 16x to the 4th over 4 factorial. We're done. I'll pause. I'll wait. Okay, moving on. Oh, another one of these? This is inside. Centered at c equals 1. So you got to remember that. So, it's only the 3rd degree. I'm so happy. So that's sine of 3x. And f prime, the derivative of x, is sine of cosine of 3x, but chain rule times 3. F double prime of x. Cosine goes to negative sine and times another 3, so negative 9. Sine of 3x. And f triple derivative of x equals, still negative 27 cosine of 3x. So plugging those in, now remember I'm centered at 1, so it makes it slightly different. My 3rd degree polynomial. I'll do this notation. Why not? We can do that. Oh, someone's at the door. You can get it. Get it, Brendan.
Thank you.
Oh, hello. Okay. For 3rd degree polynomial, let's see. You got to plug in f of 1. Oh, I never figured that out. So f of 1 would be sine of 3. Oh, that's really gross. Okay, f prime of 1 would be 3 times cosine of 3. Oh, gosh, this program is going to be really gross. So this is going to be negative 9 sine of 3. F triple derivative of 1 is negative 27 cosine of 3. Oh, whatever. It looks gross. So the formula says you do the first one, f of 1, so it'll be sine of 3. Yeah, just leave it as that. And the next one's going to be f prime of 1, so it'll be plus 3 times cosine of 3 times x minus 1 over 1 factorial, so that doesn't matter. Plus, this is going to be really gross, negative 9 sine of 3 times x minus 1 squared over 2 factorial plus negative 27 cosine of 3 x minus, okay, I'm just going to put it down here, minus 27 cosine of 3 times x minus 1 to the cubed over 3 factorial. We're done. Moving on. Oh, I got to start my meeting soon. Sorry about that. We're almost done. Sine of x cubed. We got to use the power rules right here. I'm recording. Hi, Mr. Jenkins. I'm recording for a video. It's fine. You can talk. We'll edit out and post. It's okay. No. Sine. What's the power rules? Is the sine the odds or the evens? Geez, I forget. I don't know. Lindsay. I was just about to call you Jocelyn. Yeah. Do you remember if the sines were the odds or the evens? Oh, okay. So we're going to look this up because, oh, wow. I don't remember. Okay. Sines are the odds. Okay, I forget that. Okay, odds and evens. Sure. So odds are going to be, if I did sine of x cubed and it says do it for the first four terms, so it's usually going to be x, so I'm going to say it's something, and then minus something cubed. Oh, what's the rule for it again? Oh, okay, over 3 factorial. Plus something to the 5th over 5 factorial. And then the first 4 terms would have to be one more. So minus something to the 7 over 7 factorial. So what's that something you plug in? X cubed, x cubed, x cubed, x cubed. The generic term, again, if you remember these generic terms, sure, it's negative 1 to the 2n. Oh, did they say 2n? Negative 1 to the n. 2n won't matter. No, 2n does matter. Because you start at 0. And then it'll be, instead of x to the 2n power, it's x cubed to the 2n power over 2n factorial. Or 2n minus 1, right? Something like that. I shouldn't have made you do the generic term. That's kind of weird to do. I'm going to skip that. No, I'm just going to do it anyways. Next one, e. So this one starts out with 1 plus that something squared over 2 factorial plus that something cubed over 3 factorial. What's the something? 2x. That's all you have to do. What's the generic term? So it's usually it's usually x to the n over n factorial, but in our case, it'll be 2x to the n over n factorial. Ooh, there's your generic term. Moving on. Last one, does this series converge or diverge? Hey, it's got the negative 1 dealie. So my 3 rules. Does it have the negative 1? Yes. The next one, does this part get smaller? So when I have n over n minus 1, let's start counting at 1. Okay, that's weird because you divide by 0, but let's start at 2. It's smaller starting at certain points. So it'd be, start at 2, it's 2 over 1, 3 over 2, 4 over 3, 5 over 4. Is it getting smaller? Yeah, it's getting smaller. 2, 1.5, sure. And then what about the limit? As n goes to infinity. Infinity, I fixed that. N minus 1. Well, by L'Hopital's rule, that's 0, infinity, or infinity. That's going to be 1. So that's a big nope. So this diverges. We're done. Welcome. Hope you get an A. How do I stop this? How do I stop this?